This is a narrated video series on the subject of IBM's WebSphere Java Batch. My name is Don Bagwell and I'm from the IBM Advanced Technical Skills Organization in Gaithersburg, Maryland. This is part 2 of the series. In this part, we provide an overview of the WebSphere Java Batch function. The first key concept to establish is this. The WebSphere Java Batch function is provided in two ways. Both have the same functions, it's just the packaging and delivery that is different. The first way in which WebSphere Java Batch is delivered is as a separate program product called IBM WebSphere Compute Grid version 8. This product requires a pre-existing WebSphere application server runtime to operate. The WAS runtime may be on any operating system platform supported by WebSphere Application Server itself. The compute grid function is augmented to the WAS runtime. In other words, the compute grid function is added to the WAS runtime configuration. As the chart shows, version 7 and version 8 are the supported levels for WebSphere Application Server Foundation for this solution. With WebSphere Application Server version 8.5, the compute grid function has been incorporated into the WAS Foundation product. If you acquire WebSphere Application Server version 8.5, you get the same Java Batch function you would have in Compute Grid version 8. The Compute Grid version 8 product provides a path to WebSphere Java Batch for those who have WebSphere Application Server version 7 or version 8 and are not yet ready to move to version 8.5. The separate Compute Grid product provides a means of introducing WebSphere Java Batch function to the environment without having to bring in a new version of WAS. In summary, the function is identical between the two. The packaging and delivery is different. In the first part of this video series, we introduced the concept of batch processing supported by a container within the WebSphere Application Server runtime. The benefit of a Java Batch container model is it allows the batch program to focus on the business logic while the container provides the essential batch functions and services. Let's take a closer look at what some of those functions and services are. WebSphere Java Batch provides a job dispatching and management function so you may control the execution of batch jobs within the runtime. You may submit jobs, stop and resume jobs, and view job output through this job dispatching function. Writing Java data stream handling routines is not something a batch program developer should focus on. That's a function better provided by the Java Batch container. WebSphere Java Batch provides that with a function called the Batch Data Stream Framework, which provides data access methods such as JDBC read and write and file read and write. Transactional batch jobs that perform updates to data must keep track of when the last commit processing took place. Again, that's a function better provided by the Java Batch container. WebSphere Java Batch provides a checkpoint processing based on time interval or record. WebSphere Java Batch handles the commit or rollback processing. WebSphere Java Batch keeps track of the last good checkpoint received, so jobs that are restarted pick up at that checkpoint. Long-running batch jobs that perform a lot of data I/O occasionally encounter exceptions. Rather than stop the job, WebSphere Java Batch provides a job resiliency service in the form of skip record and step retry processing. This allows long jobs to continue, which helps you meet batch completion windows. Batch jobs often lend themselves to parallel processing. That is, the range of data worked on by the batch job is partitioned into segments, and batch subjobs work on each range in parallel. WebSphere Java Batch provides a set of container services to assist in parallel processing. On ZOS, the WebSphere Java Batch function provides something called the COBOL container, which allows execution of compiled COBOL DLLs to be called and executed in the same address space as the Java Batch job. That makes calling and invoking existing COBOL assets much more efficient. There is, of course, a great deal of detail behind each of these functional services. Over the course of this video series, we will go into more detail on much of this. On this chart, we will show a bit more detail on the overall architecture of the dispatching and execution model of WebSphere Java Batch. The Job Management Console is a browser-based interface to the dispatching function. It is through the Job Management Console that you submit, monitor, and view job output. The browser interface is one such interface. The dispatching function has several, including command line, web services, and remote method invocation. An XML file called XJCL is used to describe the properties of the batch job to be run. This includes such things as the steps that make up the overall job, the Java class files that implement the batch steps, the data input and output declarations, and other substitution variables which are provided to the batch program at runtime. The job dispatching function runs in an application server and provides a set of interfaces to users who submit and manage batch jobs. One interface is for browsers, as we saw earlier. The job dispatcher takes in the submission request and the XJCL. It reads and understands the contents of the XJCL, and then it turns to the application server where the batch application is deployed and signals to the batch job execution endpoint function to invoke the Java Batch class file. The batch job executes within the JVM of the WAS app server. Multiple job execution endpoint servers may be defined. The job dispatcher is aware of their existence and what batch applications are deployed in each. The batch applications are developed using supplied WebSphere Java Batch class libraries. As a reminder, IBM Rational Application Developer 8.0.1 or higher contains support for WebSphere Java Batch application development. In summary, WebSphere Java Batch is a comprehensive batch execution platform built on the proven base of IBM WebSphere Application Server. A batch job consists of one or more job steps. The XJCL file describes the structure of the job, including job level properties as well as the specifics of each step contained in the job. The XJCL is submitted to the job dispatching function through one of the interfaces, such as the browser-based job management console. The job dispatching function interprets the XJCL and then begins the process of invoking and managing the jobs and its steps. The job dispatcher is aware of where batch application class files are deployed. When a job step calls for a specific Java class file, the dispatcher signals to the job endpoint to begin execution of that Java class file. Further, the dispatcher passes over to the endpoint an object containing all the properties specified in the XJCL. The batch step code may easily reference any job property contained in the XJCL. The job steps are executed in the order specified in the XJCL. Conditional processing is supported, so if a job step does not complete or completes with a return code higher than acceptable, the subsequent step will not execute and the overall job will go into a restartable state. Throughout this process, the job dispatcher is aware of the state of the job and its steps as it executes in the endpoint. When the job completes, you may access the job output through the job management console. That output may be viewed through the browser function or downloaded as a zip file to your workstation. A batch job goes through a series of states as it executes. The normal flow would be as shown here. A job is submitted, it executes, then it ends. But it turns out you also have the opportunity to act upon an executing job. This includes stopping the job during execution. Doing so puts the job into a restartable state. Do you recall the earlier point about checkpoint processing? The WebSphere Java Batch container maintains an awareness of the checkpoint status. This allows you to restart the job and have it pick up execution at the last committed checkpoint interval. The same holds true if a job is thrown into a restartable state because of a problem. The checkpoint processing will roll back to the last good checkpoint interval, and when you restart the job, it will pick up from that point. This is all possible because of the batch container model built on WebSphere Application Server. And if you were to try to write this function yourself, it would require a great deal of time and effort. You would end up with a custom middleware layer which would then be costly to maintain and support. With WebSphere Java Batch, all this is part of a supported IBM program product. The batch data stream framework is data input and output handling code provided by the batch container that abstracts the low-level Java stream handling. Your Java batch code focuses on business logic while WebSphere Java Batch does the heavy lifting for you. Imagine the batch container with a set of code that provides data access routines as a service to the higher-level application code. Several patterns are provided for common data access requirements, such as JDBC for relational databases, file read and write for Unix files, and ZOS dataset read and write. For this illustration, we'll use JDBC. Now, imagine a batch application performing a SQL query on a database. Now, of course, WebSphere Java Batch can't know ahead of time what SQL query command your batch program requires. Developing the batch application implies you implementing your own batch data stream based on the IBM supplied patterns. Your implementation provides the specific customization for the data record formats you know to exist. The IBM code does all the work based on your customization. Your implementation of the batch data stream then takes the query result set and begins to iterate through the records. Here's an important point. For each record in the result set, the batch data stream implementation will map the record data to a data object based on a mapping object you supply. Then for each mapped data object, your batch step is invoked and the data object is passed over. When your batch step completes processing for that record, control returns to the batch data stream, which moves to the next result set record. This continues until the end of the data is reached. So in summary, the batch data stream gets the data from the data source based on one of the supplied patterns and based on your customization of the query and data mapping rules. Each data record is mapped to a Java data object. Your batch step implementation is invoked for each record and the data object is passed. The Java code you write that performs the batch processing knows nothing of any of this. All the batch step code knows is it gets invoked and a data object is passed in. The batch step returns control and then the batch step gets invoked again, this time with a new data object. This goes on and on until the last data record is processed. Batch processing is often controlled by a higher function called an enterprise scheduler. One example of an enterprise scheduler is IBM's Tivoli workload scheduler. Imagine an enterprise scheduler in WebSphere Java Batch runtime as we've discussed. The objective is to have the enterprise scheduler submit a Java Batch job inside the batch container environment and to understand when the batch job has completed and what the return code was. But wait, there's more. The integration has to be done in a way that does not require changes to the enterprise scheduler. The enterprise scheduler has to see this integration as business as usual. So how is this done? Earlier we mentioned how the job dispatching function has several interfaces. Well, one of those interfaces is a message-driven bean interface, and that's where the integration story begins. The integration between the enterprise scheduler and the WebSphere Java Batch dispatcher is through this MDB interface and a supplied program called WS-Grid, which can be invoked as a shell script, a bat file, or using JCL on ZOS. Now, messaging implies message queues, and for this to work, two are needed, an input queue and an output queue. They may be implemented in WebSphere MQ or in the default messaging function of WebSphere Application Server. This does not require MQ. However, if you have MQ, then of course MQ works very well for this. Here's how it works. The enterprise scheduler invokes WS-Grid and passes in a few parameters related to the job to be dispatched into WebSphere Java Batch. WS-Grid puts the job submission message on the input queue, and the MDB interface of WebSphere Java Batch picks it up and begins the dispatching process. At this point, everything inside of WebSphere Java Batch is exactly as we described earlier. As the Java Batch program executes in WebSphere Java Batch, the job output records are captured and streamed back to the enterprise scheduler over the output queue. They go to the defined standard out of WS-Grid. If on ZOS, then that would be the JES spool. This serves an important role. Quite often, batch processing has important compliance and archiving requirements. For the duration of the Java Batch job's execution, the WS Grid program stays active. That's how the Enterprise Scheduler knows the Java Batch job is still running. If WS Grid is still running, then the Java Batch job is still running as well. Eventually, the job in the WebSphere Batch container environment completes and the return code flows back to WS Grid. WS Grid ends and the Enterprise Scheduler knows the Java Batch job is done. So in summary, WS Grid is seen by the Enterprise Scheduler as any other batch job or process it would submit. The Enterprise Scheduler does not know WebSphere Java Batch is in the picture. The Enterprise Scheduler does not need to understand the interface requirements of WebSphere Java Batch. To the Enterprise Scheduler, it's business as usual processing. WS Grid interacts with the MDB interface of the WebSphere Java Batch dispatching function. Output from the Java Batch job streams back to WS Grid standard out. As mentioned, WS Grid stays up for the life of the batch job in WebSphere Java Batch. That's an important point because to the Enterprise Scheduler, WS Grid is the batch job. WS Grid serves as a kind of proxy for the Java Batch job running back in the WebSphere Batch container environment. WS Grid is the glue that integrates your Enterprise Scheduler with WebSphere Java Batch. As a reminder, the WP101783 document at ibm.com/support/techdocs has a wealth of information related to WebSphere Java Batch, including a set of 2-page technical brochures, the presentation on which this video was built, as well as a more detailed technical white paper. That is the end of part 2 of this series.